Hi everyone. Okay, we're just going to finish the lesson that we started in class today. So I need you to take notes or finish the notes in your notebook from this lesson, and then we're going to do lots of practice problems tomorrow. And it'll be a good chance for those of you who are maybe still struggling with simplifying expressions to get a little more practice with that too, because we'll be using those principles and properties now, well, pretty much forever, not just in this math class, but all math classes to come. So these are the vocabulary and properties I'm going to be looking for in your notes tomorrow. We're going to go over those, whatever we didn't go over in class. Excuse me. Definition of equivalent equations, or equations that have the same solution. When solving equations, we use certain properties called the properties of equality to rewrite an equation in simpler equivalent equation, right? We want it in the simplest possible form before we try to solve it. Okay, these are the addition and subtraction properties of equality. They're in your book, but you're welcome to stop the video right now and copy them down from here. That's addition and subtraction, and here's multiplication and division. And I'm sorry that it's blurry. So when we solve one-step equations, we want to isolate the variable. And you've all heard me use this term in class already this year. We isolate the variable, but we haven't ever really given it a formal definition. So the term isolate means to get the variable with a coefficient of 1 on one side of the equation. We don't want a variable with any other coefficient. Can't be -1, can't be a 3, can't be a 4. It's got to be all by itself with a coefficient of 1, or no coefficient, because when there's no coefficient written next to a variable, it's assumed to be 1, right? Okay, and then we use properties of equality or inverse operations to rewrite our equations in simpler form and solve. So the actual definition of inverse operation is just an operation that undoes another operation, like subtraction undoes addition and division reverses multiplication, right? Old news, but formal definitions. Okay, so let's do some examples. Excuse me. Start with a nice easy one, right? 6 equals x plus 2. How hard could that be? Well, I mean, we are only doing one-step equations, right? So we can solve this in one step. What do we have to do? We're going to use an inverse operation, or we're going to use the the subtraction property of equality. However you want to look at it, we're going to subtract -2 to both sides, right? So this is the inverse. Subtraction is the inverse of addition, and the subtraction property of equality tells us that we can do this as long as we do it to both sides, and we get 4 equals x. Easy stuff. Kid stuff, right? Can't fool us. How about this guy? -17 equals 3 plus k. Well, I have to isolate k. It already has a coefficient of 1 implied there, right? So to isolate k, all I have to do is get rid of this guy. Well, that's a +3, right? So this is the same as k plus 3, right? These are equivalent expressions. Sometimes, when we write it this way, it's not obvious that this is an addition operator out here, but it is. So we need to subtract 3 from both sides. -3, -3, we get -20 equals k. How about a hard one? But not really. How about all right, well, the trick here is just knowing that our fraction is also another way of writing divided by, right? This is also a divided by bar. So the operator on this side is division. To undo that, we need the inverse operation, which is multiplication. We're going to multiply both sides by 7. These 7s cancel out. We get k with a coefficient of 1 all by itself over here, and we get whatever this is. 7 times 3 is 21, right? We get 91. Yep, that looks reasonable to me. And that's all there is to it. Stuff we've been doing for a long time. We're just giving it different terms and refining the definition a little bit. So we'll do more of these practice problems tomorrow. I am going to be checking your notes, so I want to see some stellar notes. All right, have a good night, everyone.